Hello students, welcome to Swapna physics classes. In this lecture I am going to explain you one more important short answer question for your TS IPE first year examination, and the question is define angular velocity which is denoted with omega and derive the relation V equals to R omega. What is angular velocity? Let's define. Angular velocity which is denoted with omega. It is the rate of change of angular displacement is called angular velocity. Okay, the rate of change of angular displacement is called as angular velocity. For understanding this definition, I am giving you one example. We have a circular path, okay, and the radius of this circle is r. Initially the particle is placed at point P1. After some time dt, okay, this particle is displaced to a distance of d theta. D theta is the angle made by this particle, angle made by the position vector r with this particle. Okay, and finally the particle is at point P2. Here the displacement of this particle from P1 to P2. From P1 to P2 is d theta, and the time taken to cover this distance, time taken is dt. Therefore, according to the definition, angular velocity is equal to d theta by dt, the rate of change of displacement. Okay, this is about the definition of angular velocity. We have to derive the equation V equals to R omega. Derivation for R omega. V equals to R omega. Derivation for V equals to R omega. Okay, let's consider a particle. Which is moving in a circular path. Let's consider a particle. Initially the particle is at point P, and the position vector of this particle from the origin of the circle is r. After some time this particle is moved to a distance of theta. Theta is the angle made by the position vector of this particle. Okay, so this particle will have angular velocity omega along the circular path, and also the velocity v. See, the velocity v will be always changes. Why? Because the direction of this velocity changes. If you draw the tangents for this circle at any point, okay, along these tangents we will have the velocity vector, and it always changes. Why? Because the direction changes. The direction changes here. So here r is the position vector for the particle. I am taking the distance of the particle covered as s. S is the distance covered by the particle. And v is the tangential velocity of the particle. Omega is the angular velocity. Okay, and I am going to find out the value of s here initially. For this purpose, I am considering the arc length. how to find out the arc length for a circular path? The arc length is equal to angle made by the particle into radius of the circle. You have to remember this formula, okay? Arc length, this is the arc length, which I am taking as S. Okay, this is the distance covered by the particle. I am denoting this with S, and the angle made by this particle is theta at the center of the circle, and R is the radius of the circle. Therefore, S equals to R into theta. S equals to R into theta. So we have S as R theta. Now what I am doing, I am considering this as equation number 1. Now differentiate equation 1 with respect to time. Therefore ds by dt is equal to R is constant. The radius of the circle always remains constant. So I am taking this outside into d theta by dt. Okay, what is ds by dt? ds by dt is the change of displacement with respect to time, right? Which is nothing but velocity. Okay, which is equal to R into what is d theta by dt? I just given the definition for angular velocity, right? Which is nothing but omega. D theta by dt is omega. This is the derivation for V equals to R omega. Okay.